Which theoretical model explains the stability of cycloalkanes based on angle strain and torsional strain? A. Newman's projection. B. Baeyer's strain theory. C. VSEPR theory. D. Hybridization theory. The correct answer is B. Baeyer's strain theory explains the stability of cycloalkanes by considering the angle strain and torsional strain in the molecule. Which of the following cycloalkanes would be the most stable based on Baeyer's strain theory? A. Cyclopropane. B. Cyclobutane. C. Cyclopentane. D. Cyclohexane. The correct answer is D. Cyclohexane is the most stable because it has less strain than smaller cycloalkanes. Which term describes the strain caused by deviation from the ideal bond angle in cycloalkanes, according to Baeyer's strain theory? A. Torsional strain. B. Steric strain. C. Van der Waals strain. D. Angle strain. The correct answer is D. The strain caused by deviation from the ideal bond angle in cycloalkanes is called angle strain. Baeyer's strain theory is most accurate when applied to which type of cycloalkane? A. Small ring structures. B. Large ring structures. C. Aromatic compounds. D. Aliphatic compounds. The correct answer is A. Baeyer's strain theory is most accurate when applied to small ring structures where strain effects are more pronounced. Which of the following statements is true regarding Baeyer's strain theory? A. It explains the stability of all cycloalkanes accurately. B. It does not consider the effect of ring fusion in cycloalkanes. C. It is based on molecular orbital theory. D. It cannot differentiate between different isomers. The correct answer is B. Baeyer's strain theory does not consider the effect of ring fusion in cycloalkanes, limiting its accuracy for some molecules. In Baeyer's strain theory, which factor contributes more to the overall strain in cycloalkanes, angle strain or torsional strain? A. Angle strain. B. Torsional strain. C. Both contribute equally. D. Neither contribute to strain. The correct answer is A. In Baeyer's strain theory, angle strain typically contributes more to the overall strain in cycloalkanes compared to torsional strain. Which cycloalkane has the highest strain according to Baeyer's strain theory? A. Cyclopropane. B. Cyclobutane. C. Cycloheptane. D. Cyclooctane. The correct answer is A. Cyclopropane has the highest strain. Its small ring size and high angle strain are the reasons. Baeyer's strain theory helps us understand the stability of cycloalkanes. It considers the factor present in their molecular structure. A. Rotational symmetry. B. Electronegativity. C. Strain energy. D. Hydrophobic interactions. The correct answer is C. Baeyer's strain theory helps in understanding the stability of cycloalkanes by considering the strain energy present in their molecular structure. How does Baeyer's strain theory explain the stability of larger cycloalkanes? A. Higher stability, less ring strain. B. Higher stability, increased torsional strain. C. Lower stability, increased angle strain. D. Lower stability, increased steric strain. The correct answer is A. Baeyer's strain theory predicts higher stability for cycloalkanes with larger ring sizes because the ring strain decreases with increasing ring size. In Baeyer's strain theory, what type of strain is associated with eclipsing interactions between adjacent hydrogen atoms in cycloalkanes? A. Angle strain. B. Torsional strain. C. Steric strain. D. Repulsive strain. The correct answer is B. Eclipsing interactions between adjacent hydrogen atoms in cycloalkanes are associated with torsional strain, according to Baeyer's strain theory. Bayer's strain theory predicts that the stability of cycloalkanes decreases with increasing ring strain due to A. Increased torsional strain. B. Decreased torsional strain. C. Increased angle strain. D. Decreased angle strain. The correct answer is C. Bayer's strain theory predicts that the stability of cycloalkanes decreases with increasing ring strain, primarily due to increased angle strain. Which cycloalkane would be expected to exhibit the least amount of strain based on Bayer's strain theory? A. Cyclopropane. B. Cyclobutane. C. Cyclohexane. D. Cycloheptane. The correct answer is C. Cyclohexane is expected to have the least strain. This is because of Bayer's strain theory and its lower ring strain compared to smaller cycloalkanes. How does Bayer's strain theory explain the stability trend in monocyclic cycloalkanes as ring size increases? A. Stability decreases due to increased angle strain. B. Stability increases due to decreased torsional strain. C. Stability increases due to decreased ring strain. D. Stability decreases due to increased torsional strain. The correct answer is C. In Bayer's strain theory, stability increases in monocyclic cycloalkanes with increasing ring size due to decreased ring strain. Which term describes the strain caused by deviation from the ideal bond angle in cycloalkanes, according to Bayer's strain theory? A. Eclipsing strain. B. Steric strain. C. Angle strain. D. Stereochemical strain. The correct answer is C. The strain caused by the deviation from the ideal bond angle in cycloalkanes is termed angle strain, according to Bayer's strain theory. Bayer's strain theory predicts cycloalkane stability trends that correlate with what? A. The number of carbons in the ring only. B. The type of carbon atom hybridization only. C. The type of strain in the molecule. D. The ring size and the type of strain present. The correct answer is D. The stability trend of cycloalkanes predicted by Bayer's strain theory correlates with ring size and the type of strain present. Thus considers both angle and torsional strain. According to Bayer's strain theory, what type of strain is caused by deviation from the ideal bond angle in cycloalkanes? A. Angle strain. B. Torsional strain. C. Steric strain. D. Eclipsing strain. The correct answer is A. According to Bayer's strain theory, the strain caused by deviation from the ideal bond angle in cycloalkanes is referred to as angle strain. Bayer's strain theory best predicts the stability of which type of cycloalkane? A. Small rings. B. Medium rings. C. Large rings. D. Polycyclic rings. The correct answer is A. Bayer's strain theory is most accurate when applied to small cycloalkanes with fewer ring carbons. What major factors contribute to the strain in cycloalkanes according to Bayer's strain theory? A. Eclipsing strain only. B. Torsional strain only. C. Angle strain only. D. Both angle strain and torsional strain. The correct answer is D. Bayer's strain theory considers both angle strain and torsional strain as major factors contributing to the overall strain in cycloalkanes. What's the main difference between angle strain and torsional strain in cycloalkane stability, according to Bayer's strain theory? A. Angle strain is caused by deviations from ideal bond angles, while torsional strain is due to eclipsing interactions between atoms. B. Angle strain arises from eclipsing interactions between adjacent hydrogens, while torsional strain results from ring puckering. C. Angle strain is related to eclipsing interactions, while torsional strain is associated with deviation from ideal bond angles. D. Angle strain contributes more to overall strain than torsional strain, based on Bayer's theory. A. None of the above. The correct answer is A. Angle strain is the strain caused by deviation from ideal bond angles in cycloalkanes. Torsional strain is the strain from eclipsing interactions between atoms, like hydrogen atoms. Bayer's strain theory considers both types of strain when assessing stability. What is the primary focus of Bayer's strain theory when analyzing the stability of cycloalkanes? A. Angle strain and torsional strain are equally important factors in determining stability. B. The presence of bridgehead carbons and their impact on stability. C. The prediction of stability based on the ring size of cycloalkanes. D. The contribution of angle strain and torsional strain to the overall strain in cycloalkanes. A. None of the above. The correct answer is D. Bayer's strain theory focuses on angle strain and torsional strain in cycloalkanes, affecting their stability. Which type of strain in cycloalkanes is primarily associated with eclipsing interactions between adjacent hydrogen atoms, according to Bayer's strain theory? A. Angle strain. B. Torsional strain. C. Steric strain. D. Puckering strain. A. None of the above. The correct answer is B. Torsional strain in cycloalkanes is primarily associated with eclipsing interactions between adjacent hydrogen atoms, influencing the overall stability according to Bayer's strain theory. How does Bayer's strain theory predict the stability of cycloalkanes as ring strain increases? A. Increased ring strain leads to higher stability in cycloalkanes. B. The stability decreases with rising ring strain due to elevated angle and torsional strain. C. Ring strain does not affect the stability of cycloalkanes according to Bayer's strain theory. D. Stability remains constant regardless of the ring strain in cycloalkanes. A. None of the above. The correct answer is B. According to Bayer's strain theory, the stability of cycloalkanes decreases as ring strain increases. Higher ring strain leads to elevated angle and torsional strain, reducing overall stability. What major factors contribute to the strain in cycloalkanes according to Bayer's strain theory? A. Steric strain and puckering strain. B. Eclipsing interactions and bridgehead carbons. C. Angle strain and torsional strain. D. Ring size and aromaticity. A. None of the above. The correct answer is C. According to Bayer's strain theory, the major factors contributing to strain in cycloalkanes are angle strain from deviations in ideal bond angles, and torsional strain from eclipsing interactions between adjacent atoms. In Bayer's strain theory, what type of strain is related to bending bond angles away from their ideal values? A. Torsional strain. B. Eclipsing strain. C. Angle strain. D. Steric strain. The correct answer is C. Angle strain in Bayer's strain theory refers to the strain caused by deviation from ideal bond angles in cyclic compounds. Which cycloalkane would be expected to have the most strain according to Bayer's strain theory? A. Cyclopropane. B. Cyclobutane. C. Cyclopentane. D. Cyclohexane. The correct answer is A. Cyclopropane is expected to have the highest strain due to the severe angle strain in its structure. According to Bayer's strain theory, what contributes more to strain in cyclic compounds? Angle strain or torsional strain? A. Angle strain. B. Torsional strain. C. Both contribute equally. D. Neither. The correct answer is A. Bayer's strain theory emphasizes that angle strain is the primary source of strain in cyclic compounds. What type of strain is mainly responsible for the high reactivity and instability of small cycloalkanes, according to Bayer's strain theory? A. Torsional strain. B. Angle strain. C. Steric strain. D. Conformational strain. The correct answer is B. Small cycloalkanes exhibit high reactivity and instability due to significant angle strain, as per Bayer's strain theory. Which term describes the strain caused by deviations from ideal tetrahedral bond angles in cycloalkanes? According to Bayer's strain theory, A. Steric strain. B. Eclipsing strain. C. Torsional strain. D. Angle strain. The correct answer is D. Angle strain in cycloalkanes results from deviations from the ideal tetrahedral bond angles. This is a key concept in Bayer's strain theory. Bayer's strain theory best explains the stability of which cycloalkanes? A. Small ring compounds. B. Medium ring compounds. C. Large ring compounds. D. Bridged ring compounds. The correct answer is A. Bayer's strain theory is most accurate when applied to small ring compounds, due to the prominence of angle strain and torsional strain in their structures. Bayer's strain theory predicts that the stability of cycloalkanes decreases as ring strain increases. This is mainly because of A. Increased torsional strain. B. Increased angle strain. C. Decreased torsional strain. D. None of the above. The correct answer is B. Bayer's strain theory suggests that as ring strain increases, due to increased angle strain, the stability of cycloalkanes decreases. What concept in Bayer's strain theory helps understand strain in cycloalkanes due to deviations from ideal bond angles? A. Steric interaction theory. B. Eclipsing strain theory. C. Angle strain theory. D. Torsional strain theory. The correct answer is C. Bayer's strain theory focuses on angle strain as a crucial element in understanding the stability of cycloalkanes. What major factors contribute to the strain observed in cycloalkanes according to Bayer's strain theory? A. Angle strain only. B. Torsional strain only. C. Steric strain and van der Waals forces. D. Angle strain and torsional strain. The correct answer is D. Bayer's strain theory considers both angle strain and torsional strain as major factors contributing to the strain in cycloalkanes. Which cycloalkane would be expected to have the least amount of strain based on Bayer's strain theory? A. Cyclopropane. B. Cyclobutane. C. Cyclopentane. D. Cyclohexane. The correct answer is D. Cyclohexane is expected to have the least amount of strain among the options, due to reduced angle strain and torsional strain in its six-membered ring structure. What term describes the strain caused by deviations from ideal tetrahedral bond angles in cycloalkanes? According to Bayer's strain theory, A. Ring strain. B. Torsional strain. C. Angle strain. D. Steric strain. The correct answer is C. Angle strain in cycloalkanes is the strain caused by deviations from ideal tetrahedral bond angles, as stated by Bayer's strain theory. In Bayer's strain theory, what factor contributes more to the overall strain in cycloalkanes? Angle strain or torsional strain? A. Angle strain. B. Torsional strain. C. Both contribute equally. D. Neither. It is a combination of Steric and van der Waals forces. The correct answer is A. In Bayer's strain theory, angle strain contributes more to the overall strain in cycloalkanes than torsional strain. What limitation of Bayer's strain theory makes it challenging to explain the stability of cycloalkanes with bridgehead carbons? A. Inability to account for torsional strain. B. Difficulty in predicting stability trends. C. Underestimation of steric hindrance effects. D. Neglect of steric strain at bridgehead carbons. The correct answer is D. Bayer's strain theory has trouble explaining the stability of cycloalkanes with bridgehead carbons. It ignores steric strain from those specific carbons. What type of strain in cycloalkanes is primarily associated with eclipsing interactions between adjacent hydrogen atoms, according to Bayer's strain theory? A. Angle strain. B. Torsional strain. C. Steric strain. D. Van der Waals strain. The correct answer is B. Torsional strain in cycloalkanes is primarily associated with eclipsing interactions between adjacent hydrogen atoms, as stated in Bayer's strain theory. Based on Bayer's strain theory, which cycloalkane would be expected to have the most strain? A. Cyclohexane. B. Cyclooctane. C. Cyclopropane. D. Cyclobutane. The correct answer is C. Cyclopropane is expected to have the most strain due to the high angle strain associated with its bond angles. What is the source of strain in cyclic compounds, according to Bayer's strain theory? A. Eclipsed interactions. B. Bond length discrepancies. C. Torsional strain. D. Deviation from ideal bond angles. The correct answer is D. Deviation from ideal bond angles is the source of strain in cyclic compounds, according to Bayer's strain theory. In Bayer's strain theory, what type of strain is related to bending bond angles away from their ideal values? A. Torsional strain. B. Steric strain. C. Angle strain. D. Ring strain. The correct answer is C. Angle strain is related to the bending of bond angles away from their ideal values, according to Bayer's strain theory. Which cycloalkane would be expected to have the least amount of strain based on Bayer's strain theory? A. Cyclopropane. B. Cyclohexane. C. Cyclopentane. D. Cycloheptane. The correct answer is B. Cyclohexane is expected to have the least strain, because of its low angle strain compared to smaller cycloalkanes. What term describes the strain caused by deviations from ideal tetrahedral bond angles in cycloalkanes, according to Bayer's strain theory? A. Torsional strain. B. Steric strain. C. Ring strain. D. Angle strain. The correct answer is D. Angle strain is the term describing strain from deviations in ideal tetrahedral bond angles in cycloalkanes, according to Bayer's strain theory. What is the primary focus of Bayer's strain theory in understanding the stability of cycloalkanes? A. Torsional strain. B. Bridgehead carbons. C. Angle strain. D. Steric hindrance. The correct answer is C. Bayer's strain theory primarily focuses on the angle strain in cycloalkanes to explain their stability. How does Bayer's strain theory explain the stability of cycloalkanes with larger ring sizes? A. By considering steric hindrance effects. B. By emphasizing torsional strain. C. By accounting for the decrease in angle strain. D. By incorporating bridgehead carbons theory. The correct answer is C. Bayer's strain theory explains that with larger ring sizes, the angle strain decreases, leading to increased stability. Which type of strain is primarily responsible for the high reactivity and instability of small cycloalkanes, according to Bayer's strain theory? A. Eclipsing strain. B. Torsional strain. C. Steric strain. D. Angle strain. The correct answer is D. In small cycloalkanes, angle strain is the primary factor contributing to their high reactivity and instability, according to Bayer's strain theory. What term describes the strain caused by deviations from ideal bond angles in cycloalkanes, according to Bayer's strain theory? A. Torsional strain. B. Steric hindrance. C. Eclipsing strain. D. Angle strain. The correct answer is D. The strain caused by deviations from ideal bond angles in cycloalkanes is referred to as angle strain in Bayer's strain theory.